I spent a lot of time the last few days trying to figure out what I wanted to say about David. And, just my 15 minutes are not enough. But I decided maybe what I would do would be to go back and look at, before we started DIMACS and the influence that David had on this organization. And so I actually found the original proposal that we wrote. And that is not, it was not a trivial activity because it was somewhere in a drawer and I wasn't sure which drawer it was in. And when I finally found the drawer, it was blocked by a bunch of boxes. So, but because this was important, I managed to move all the boxes, got the proposal out, and then I said, I got to find David in this. Now, this was a 150-page proposal to NSF. I finally found his CV on page 103. So if you want to know what David Johnson was like in 1988, having won the Lanchester Prize, having published a variety of papers, it's interesting to see his current research interests. Not that different. So I dug further into this and wanted to see how much David was involved in the original proposal for DIMACS. And I wasn't surprised, even though I didn't remember any of it, to find his name in various groups that we put together. So we organized this proposal around various research groups. So group number 3 was the Data Structures and Algorithms group. And if you can read the small print, you'll see a lot of names that you'll probably recognize. I've circled the important name, of course. So this was one of the groups, had to do with construction of efficient problem-solving methods and algorithm design and so on and so forth. So anyone want to guess how many of the groups David was involved in? There were probably about 15 groups altogether.
We know he wasn't in 1 or 2. We're afraid
Yeah, well, think about your best guess. Here's the complexity of computation. No surprise about that one. And it is interesting to go back and look and see what we said. And I'm going to come back to that a little bit later. But so there was a really powerful group involved in complexity of computation, of which David was, of course, a key member. All right, that was number 4. Number 9 was graph theory. And it was amazing what we wrote about graph theory. All we could think of was talk about the Königsberg Bridge problem. Yeah. And we had come a long way since then, thanks in large part to David's leadership. But graph theory was the 3rd example. We also had a bunch of applied groups. It should come as a shock that he was involved in a telecommunications group. So this one had to do with modern information society. Really, it is fascinating reading what we thought modern information society was like. It was also involved in a second application group, a transportation systems group. And actually, that was one, I would say it failed because we didn't do much with transportation systems in all the years we've had DIMACS. But I'm not going to blame it on David, because he was involved in so many things. So here you go, David Johnson, 5 out of about 15 research groups already in the original proposal for DIMACS. So what happened after that? In 1989, we got the DIMACS Center Award from NSF. And then we had this crazy idea of organizing special years. Later became special focus programs. And I went back to look and see, because I knew that David was heavily involved in the special year program, but didn't remember how many special years he had organized. So this was our third special year. It was on graph theory and algorithms, well, consistent with our original working group and proposal. And that year was a really nice year. It focused on things like extremal graphs. And it went to expander graphs. It talked about graph embeddings and parallel architectures. It went on to applications of graph theory and algorithms. If you look on the DIMACS website, you'll actually see written reports about how successful the early special years were, and I think David is among those who was mostly responsible for that. So along came the next year, and here he is again, combinatorial optimization, special year number 4 at DIMACS, 1992 to 1993. Good to see Bill Cook is here. He was involved in that too. And so there we did things like TSP, we talked about linear and integer programming, and we talked about perfect graphs and network flows, and another really nice David Johnson organized special year. So then we got a little bit more complicated. We created a special year on networks in 1996 that dealt with network security and network applications and network control and network design. And lo and behold, this was not a special year. It lasted 4 years. And again, I give David a lot of credit. We had a lot of discussion about what our special years should be, and eventually came around to the idea that you can't spend so much time building up for a special year and then have it end in a year. And so we evolved to things that lasted longer. So I like to say that David Johnson organized a special year that lasted 4 years. So the last one that he was involved in as an organizer was computational intractability. That lasted 3 years, ended in 2001, and there we looked at algorithms for hard problems, of course, but there was also a new piece to that, and that was outreach to other areas of mathematics, like algebraic geometry and topology, and things of that sort. So having known David and seen him organizing things, he was always willing to try to reach out and involve others and other fields and other topics. So I looked through to see if there were any of David's talks that I could find on the DIMACS website. And I picked up one that I wanted to emphasize because it took place in a workshop of all things called experimental analysis of algorithms. This was one that was the result of a dialogue that we tried to create between the statisticians and the operations researchers, and to see if there were ways of collaborating and ways of bringing statistical concepts into the analysis of algorithms, and vice versa, bringing combinatorial optimization ideas into statistics. And so we looked at things like estimating asymptotic performance and sampling and experimental designs. We looked at use of statistical methods to identify the key contributors to running time. We looked at design of convergence tests and stopping criteria. We looked at analyzing streaming data and so on. Actually, this was one of David's failures.
How was that workshop?
We never pulled off the special year that we wanted to build on this topic. And I don't blame David, or even if I did blame him, you're not going to hear me blame him. But no, he played a really important role in this topic, and it's something we may, in memory of David, want to revisit at some time. I did find the title slide from his presentation at that workshop, and his inimitable form of giving slides, if you remember what they looked like. And It was 86 pages. I didn't want to put 86 pages on this computer, but so in the early years of DIMACS, we had things called mixers. Those were alcoholic, but not alcoholic mixers. They were the way we could start creating a new center out of 4 disparate organizations, and how we all knew each other a little bit, but getting together at Bell Labs, for instance, in the early years of DIMACS, and having each of us talk a little bit about what we're interested in, what we're doing, that created the DIMACS community, and David played an absolutely essential role in having that happen. He was a constant presence at DIMACS events, with or without alcohol. And he was a constant presence in the DIMACS management. He was on the executive committee for years and years and years, and I would think the way I would describe David's role in the executive committee, he never lost his patience. He was a calm voice of reason, and he was also an organizer and a leader. And he came up with new ideas. He asked good questions of those who came up with ideas, and he was an absolutely essential player in the history of DIMACS and the decisions about what we would do. So I have to mention his books. We actually had, how many of you know how many books we had in the DIMACS series? What's your best guess? Go ahead. We had 76 books in the DIMACS series with the American Mathematical Society. David actually was the editor of more than 5% of them, and which, if you can quickly do the arithmetic, it was 4 books. And there were many other books about the special years he organized that he wasn't an editor of, but he was an absolute critical presence in. So the books basically that we published in the DIMACS series came out of the implementation challenges. So there was the network flows and matching, there was the cliques, coloring, and satisfiability book. There was the data structures and near neighbor searches book, and there was the shortest path problem book, which was book 74 in the series. So you don't want to know why we ended the series. It was not because of David Johnson's book 74, but he certainly was a major contributor to this as well. And if you look at the DIMACS books, you will actually see him named in many more of them than simply the ones he edited, either because he had a contribution to the book or because he helped with the preface or one thing or another. So David was an amazing expositor. It was great always to listen to him, and I always felt like I learned something whenever I heard him talk. And let me close by going back to the original DIMACS proposal, because I wanted to see what we actually promised we would do and what we actually accomplished. And so we promised workshops. And what the proposal said was a number of research workshops will be held each year. So imagine this proposal would never have cut bait at NSF nowadays. It was about as vague a proposal as you could get. Well, we were naive. We had no idea what we were getting into, and there was one year where we ran over 25 research workshops. DIMACS doesn't do that anymore, but we still run a lot. And I think David's fingerprints were all over so many of those workshops. So what else did we promise? The special year model. Each year, 1 or perhaps 2 topics will be singled out for special research focus. This became the unique thing that DIMACS did. The rotating research foci was very different from every other science and technology center that NSF funded, because every other one had one theme and one group of investigators, and they were the same people year in and year out, working on the same basic set of research challenges. We were different. We started with relatively conservative and traditional research foci, and then all of a sudden we got much more complex and much more multidisciplinary and much more ambitious, and of course, longer. Instead of 1 year, we went to 4 years, and instead of one special year at a time, there was a point where we had 5. And again, David's fingerprints were all over this, in the choice of them, in the choice of the organizers, in the twisting arms of getting people to organize things. The other thing that was different about DIMACS is that no organizer was ever paid for organizing a special year or a workshop. Very different from any other science and technology center. It was only because of the involvement of leaders like David that we were able to pull that off. So what else did we promise? Complexity of computation. Whether these results about bounds on complexity will be of use remains to be determined. But there is increasing evidence that solutions to these problems will of necessity depend on combinatorial methods. Again, kind of vague promise. What actually happened? Well, we know there were major solutions to major problems, major new directions, and David's fingerprints were all over those as well. Whether it was progress on the TSP or on network flows or on shortest path or on the theory of approximate algorithms, which hardly existed before some of our special focus programs that David was involved in got underway. So maybe I should end with what we said about experimental computing. Computational experimentation is an appropriate and at times the only vehicle for introducing students to the field of data structures and good implementations, and for capturing the immediate interest of practitioners. And I think it's fair to say that that kind of vague claim was too modest, to say the least, especially with a leader like David. I think it's fair to say that thanks to David's leadership, theoretical researchers and students and practitioners have all been introduced to the vital role of doing experiments as you try to develop good algorithms. And you, in the end, discover some new theorems as well. And certainly the implementation challenges reflect that, but they're only part of it. So I think David's fingerprints were all over so much of the research breakthroughs that came through in EAA and so on. So thank you, David. We miss you. DIMACS is what it is to a large extent to your contributions, and your fingerprints continue to be involved with the achievements as we continue.